We are live now.
Okay. All right. It is start time. So I'd just like to mention right up front that what I'll do is leave maybe 1 more minute because people are still joining, and then we will start. So just another minute and we'll get going properly. Thanks. My computer's telling me that the minute is up, but it seems very short amount of time. But anyway, I'd like to get going. Firstly, I'm Bruce McCormack. I'm the Vice President of EUROGI, and it is our great pleasure to welcome Ben to present this webinar. And I'm absolutely certain I know Ben from a number of years, I'm absolutely certain it's going to be very interesting and we are going to learn a lot. Just a few housekeeping things. The first one is that this webinar is being recorded. So just to let you know about that. And secondly, if you've got any comments or any thoughts, questions, whatever, during Ben's presentation, there's a Q&A button at the top in the middle, and please just put your questions or comments into the Q&A, and at the end of Ben's formal presentation, he will respond to the questions or comments. So that's really what is by way of the sort of housekeeping rules. You can see from this slide that the title of the webinar is Co-Designed Open Source Solutions for Climate Change Adaptation and Disaster Risk Management. Both of them are really, really important topical topics. So I'm certainly looking forward to hearing what Ben has to say. But just the next slide, please. It would be a little bit about EUROGI for those who are new and don't really know what EUROGI is about. EUROGI stands for European Umbrella Organization for Geographic Information, and as you can see there, was established just over 20 years ago at the request and facilitated by the European Commission. In fact, they provided the first 2 years of funding to let EUROGI get off the ground. So here we are, just over 20 years later. The mission, as you could see, to promote the widespread and effective use of geospatial information, analytics and technologies across Europe. When we say Europe, it's the Council of Europe. It's not the EU, it's Europe, the full Europe. The membership, as I mentioned in the beginning when I was saying what EUROGI meant, it's an umbrella organization with national GI associations. It has public and private sector members, university members and NGOs. And just recently, we've had our first municipality of Lucerne in Switzerland, municipality member. We've only... oh, excuse me. We've only 21 actual members, but our members collectively have many thousands of their own members. So we have a very large network with an enormous pool of expertise lying there in the background. What we do webinars, courses, presentations, awards, lobbying, networking, and we get involved in projects when that's a feasible case for us to do. The benefits of membership, networking, we got this large network, and certainly you can meet people from whatever field of expertise you would like to meet people from. And we contribute to lobbying. We have more recently submitted a whole lot of views to the European Commission, and we also will be giving a presentation at a conference coming up next year, which is the mix of national mapping agencies and statistics agencies. So lobbying, networking projects, etc. And also there's an opportunity for people to present their own projects or best practices. Now that's actually what's going on today, because Ben has been involved in the project you will hear about. So it's showcasing something that he feels good about and for which there's an interest amongst the wider membership. So I think that's pretty much all that I have to say. You haven't really come to listen to me. So Ben, would like to hand over to you. If you could just give a little bit about sort of verbal short background about yourself and your company.
Sure. Thanks a lot, Bruce. Welcome everybody to this webinar. So my name is Benedikt Gräler, or Ben for short, as Bruce said it. By training, I'm a mathematician and did my PhD in geoinformatics afterwards, trained here in Münster at the Institute for Geoinformatics in Germany. And after some time as postdoc, I kind of turned over to the 52 Degrees North company, which is a private research company, also based here in Münster, where we develop different spatial data infrastructures, information products, different tools, very active in open source software development and open standards. So from the OGC, and contribute there to different working groups and develop prototypes, and also engage in research projects, and two of which, and their kind of joint results, which I will present today. Next to research projects, which can be international, European most likely, but also national. We also offer professional services to kind of support the research development we do, as it is always an investment, so to speak. So that's kind of the mix of 15 hours, which is like 25 employees we have currently with different backgrounds on geoinformatics, informatics, mathematics, just to give a range. And of course, also looking to spatial data science, spatial statistics on my side, but also innovative solutions, emerging IT trends and developments, and all typically leading to open source developments, either contributing to existing solutions or kind of also providing completely new solutions that we have developed in our projects. But let's get started.
Ben, could you just mention you part of DDGI and
of course.
as a member of EUROGI?
Yeah. Thanks for that reminder. Sorry. So officially, I'm a member to EUROGI. So 50 Degrees North is part of the DDGI, which is the German umbrella organization for geoinformation. And DDGI is again the member of EUROGI. And that kind of shows how this network works. As Bruce said, that leads to kind of thousands of members in this network at the end. And for DDGI, I'm the European representative of the GGI management board. And that's kind of also my direct link to EUROGI, besides being member. Right. Thanks for that reminder, Bruce. So then let me pull up my presenter's view here. So then we get started. Here we go. So I'd like to present some results and insights and kind of the way how we approached it, some learnings inside for you, how we kind of co-design different open source solutions that support climate change adaptation and also support disaster risk management in different applications. So to briefly let you know what kind of address today of the welcome logistics, we did that already. Then let's start by setting the scene. So why are we doing these activities? How and what do we would like to achieve here? And then I would like to take you with me into those two example projects that I'm going to be presenting, kind of looking to co-design and co-development of the solutions, why we use open source solutions and how we use interoperability tools, and then present a couple of examples of available, also online available, I share the links later, from the I-CISK Interacted project, what kind of prototypes we have developed that can be used and exploited and taken up. And then to summarize outcome and conclusions, and then at the end, of course, acknowledgements to the project partners. That to say upfront, that's not all based on our expertise and on our team and staff. So it's not only presentation by 50 Degrees North, but it's also presentation by all partners and members involved in the two research projects, I-CISK and Directed. And at the end of this webinar, towards quarter to 3, I guess, we will start in the Q&A part so that you can raise your questions and I'll try to answer them as good as I can. So let's set the scene. Where are we up to? So start with the why. Business as usual, that's what we see, is likely to fail. So that doesn't work anymore as we used to it. So we have to kind of take some actions, because what we all know, our world is changing. And that means also the constraints are changing of different processes, of relationships, of things we are used to in different fields of applications and different domains. So that's an important thing we have to kind of take into account. And if we try to do kind of to react to those changed constraints, and we're not well informed to take those decisions, how to react, then we often trigger even unintended consequences that might in the end do more harm than good. So that's important to know in advance and to have kind of good information tools to really take well-informed decisions for your daily life and kind of daily business operations you might have. So what we see is businesses, infrastructures, people, societies, economy, the planet itself is at a risk. The relationships behind it are very complex, so it's not easy to kind of address those changes and to address them properly. So that might need some tools to do it. And measures we see are often costly, so it's very important to know kind of which measure to take if it's very expensive. And sometimes they're also uncomfortable. So there might be good measures, but they might not be well accepted because they're quite uncomfortable. So that's why business as usual is likely to fail. How are we addressing it? We would like to provide tailored information for decision taking so that people get the information they need to take their decisions tailored to their scope of action so that they can really take a benefit from it and that's really meaningful to them locally. And how we can do that is can we engage end users and stakeholders into the entire process to learn with them and from them how their decisions they're taking on a daily basis will change under a different climate, under different constraints, different conditions in this changing world. So what we do is kind of like to make existing high-level data that is available accessible and also locally meaningful to our users and stakeholders that work with us and that we have in mind here. We need to open up data silos, which are still there, even though we have interoperability standards around. We need to connect the data to the models and the models to the information products so that we can have executable, machine-readable change that can turn new data, real-time data, into the right information products for our users in mind. And also kind of improving the cooperation among institutions and across boundaries, which is not only a technical solution, which is of course a governance issue. So how can different institutions work together? How can they communicate? Who informs whom to which point of time? Who has the same or making the same data available to them so that they can take this decisions based on the same information they have. So it's kind of partly a technical solution, but the more tricky part here is to kind of overcome the governance issue behind it, who's responsible, who may warn, who may not warn, and so forth. That's a huge issue on its own that we can't address here with technical staff only. And what we're going to do, so we decided or thought it would be best to have co-developed open source solutions to address those points. And so we head off to kind of co-design the information products based on the specific needs that we learned from the living labs, from the users that we work with. And they also should be kind of tailored to the scope of action so that we really kind of know what are the different decisions people can take and that we get information to take those decisions. And we also engaged in co-development of the user interface and the user experience. So making sure that they really like the tool that we develop and know how to use it from the beginning and not just kind of overwhelmed by a number of functionalities or layers or something. So we take up the users from the beginning to let them learn how to use the interface that we're developing. And we believe that open source solutions a very sustainable way, that's kind of easy to reuse, and there's an easy way to uptake because there's no licensing involved, and it's also kind of a growing base because we also use in our approach existing open source solutions and just kind of extend them or feedback to the open source community to have this kind of wealth of growing software. And of course, we have to foster interoperability. So if we have kind of to open up those silos, if we want to connect data models and information products, we have to use an interoperability approach that makes this possible. That's kind of a bit of motivation. So we did this in 2 European projects, the I-CISK and the Adaptation project, which I briefly mentioned. I-CISK is an Horizon 2020 project about to end in the next couple of days. Here we work together with 7 living labs in total, 5 across Europe, and then 1 in Georgia and 1 in Lesotho. And what we headed out here was kind of develop an innovative cloud-based platform for climate services that we developed in the end, and where we'll show 2 use cases during the presentation today. And then the Directed project, which is a bit younger and hence is a Horizon Europe project, still 1 year to go. Here we have a similar setup, but 4 living labs that are distributed across Europe. And here the ambition is to look into multi-hazard risk management, but also through interoperability and co-creation. So also co-designing and co-developing solutions and tools that support climate change adaptation and disaster risk measures. So if we dive into those projects, first I have to explain kind of the co-design that we did with the living labs, which is pretty similar in both projects, so just kind of have it here once. So altogether, across the 2 projects, we have a variety of climatic and environmental conditions. So we have Denmark in the north as the far most north living lab we have, and then kind of in South Europe, we have Andalusia in Spain, but also, of course, Lesotho, Crete in Greece. We also have Georgia as kind of more eastern part, so kind of very well distributed and also in kind of very different climatic zones, and bringing kind of different environmental conditions, but also very different use cases and very different application domains in different sectors. So we work together with users and stakeholders from agriculture, from hydropower production, from the tourism sector, but also urban planning, different local, regional, or national authorities. So very mixed water boards, not to forget. So this kind of makes up this diverse stakeholder group. We really work together with farmers, and also there we have kind of farming of crops, of livestock. We also have tree nurseries here, and also there are cooperatives which then connect different farms into kind of joint efforts. The local, regional, national environmental agency, but also public authorities, the emergency authorities, and first responders, water boards, different companies, for instance, the hydropower company, but also from the insurance sector or from the tourism sector. We work together with hotels to understand what are their kind of burning questions on climate change adaptation. And we also had NGOs in the group of stakeholders, and sometimes also just the general public. So kind of very mixed, very diverse, which is kind of a challenge in its own, but also a very nice opportunity to work together with all those different people in their own specific living labs. So it's not that we put them all together on a huge table. That happened in their respective living labs they come from. Each living lab was or is managed by a host that kind of is a partner in the project, but of course every living lab is also supported by all the partners of the projects with our kind of different expertise. We have different approaches. It's not only technical partners, but it's also partners from social sciences, humanities, that bring in their expertise here to kind of improve disaster risk management and climate change adaptation as a kind of entire process. So said not only technically, but also on the governance side, for instance, to kind of raise understanding and provide measures that work well in the end. The process here was kind of on-site, but also online workshops, kind of to raise the larger questions, to present the tools to stakeholders, to kind of first, of course, assessing the status quo, and but then kind of really understanding what are the different needs of all those different stakeholders, different partners across all those different living labs. And in the end, really kind of technical detailed discussions, also discussing wireframes, how should the interface look like in the end, discussing first mock-ups and early and later prototypes, and also use this kind of context to validate our solution and to see if it's really helpful and can really serve as a benefit for the living labs. And of course, the living labs themselves have also been involved in communication, dissemination, and exploitation activities, so that we can spread the word about the solutions and kind of let people know what we're doing here. I also mentioned here asynchronous workshops, or working together asynchronously. That also worked pretty well. We then used just kind of screenshots of our current prototype, and then the living lab hosts and stakeholders could comment on those screenshots, and we could collect those feedback in iterative loops. That could be just a simple slide with a screenshot, or could also be Miro as a technical solution to kind of make this co-design happening here. And that led to an iterative and agile co-development process, which we then kind of split up the team into smaller task forces. So there was on this still a task force per living lab, and the product owner deciding kind of what we're going to develop here. That was kind of a person from the living lab as representative, and kind of a spokesperson to the stakeholders on his side, and then kind of in this task force discussing with IT and modelers how to kind of develop the tool here further. And the task force further kind of contained a representative from each work package, which then was, for instance, a modeler, somebody from the governance team, somebody from data and infrastructure team. And then those task forces kind of met regularly in sprint meetings, mostly every third week. And then they reviewed the process and the features that have been implemented, and kind of decided how to kind of progress and how to prioritize all the features that were on the wish list, to kind of come to the tool that everybody wanted to see. We also kind of followed an early deployment and rapid prototyping approach, so that users and stakeholders could, from the beginning, explore and see the tool, and then give early feedback to let us know if it's going in the right direction. And that led, in the end, to a jointly developed cloud-based platform, where many different climate services have evolved over time and are used in the living labs by now. On the open source side, we built upon existing solutions and also contributed back to those open source communities that are developing those solutions. So some prominent components that we use, quite central one for us, is the GeoServer and also the PyGeo API that provides different interfaces to different standards that we used quite a lot. And everything is deployed in the cloud as kind of modular system in the Open Telecom Cloud, to choose a European cloud provider, and runs in Kubernetes and of course Docker. And yeah, that's kind of the largest components, but of course there are many more established packages and components in the background that we just use and build upon. And then we developed kind of a modern React-based web application as a front end, and that was based on the Open Pioneer Trails framework, to have that kind of very nicely integrated with web functionalities and recent activities. We also based our development on the kind of new OGC standards, which are the OGC APIs, like features, like API maps, API processes. But in some cases also use kind of the classical OGC standards, like the web mapping service, depending on the data source that we integrate. Because we also kind of approached it here, kind of also the data access side on an interoperable perspective, not just copying all the data, but also accessing remote data and that integrating into our front-end components, so that not we host all the data, but we also use external resources to kind of build it in on the fly. But of course, we also use a lot of existing data from Copernicus, most likely for the climate projections and forecast on a larger area and a bit more high level. But we also integrated local data providers to provide really meaningful local data and do some bias correction and downscaling to the local conditions, so that the results really map the experience and expectations of our users and stakeholders that we have here. And what we also did kind of to make those models more interoperable and interchangeable also, revamped those modeling functionalities, which are then written in different code by different partners, into an executable OGC API processes, so that we can just call them machine readably from remote, more or less, and kind of integrate the results into our processes and our information tools that we have developed. There's been a lot of description of the process so far, so I thought it would be helpful to also have some examples and to see what actually is the outcome. So I start with 2 examples from the I-CISK project. As said, it's 7 living labs, but you see kind of 8 tiles here. We also developed a climate service auto-composer based on a large language model, which is not yet suitable for end users, but could be an interesting starting point for climate service experts and modelers. What you get in the end is a Jupyter notebook that can automatically access data sets from remote and provide some visualization tools and be helpful here. But you can kind of interact with the setup of the Jupyter notebook through the large language model and ask for different regions of the world, to ask for different indicators that you would like to see. So that's also kind of like a flexible 8 living lab, if you will. But we have those 7 living labs, so Lazani Basin in Georgia, city Budapest in Hungary, the island of Crete in Greece, the Emilia-Romagna region in Italy, the Andalusia living lab in Spain, and Soto in Africa, and the 7th living lab here is the Rhineland from the Netherlands. And the 7th one, the Rhineland, is also the one we're going to start with. It's, well, as the name said, located in Rhineland, which is kind of part of the Rhine Delta in the West Netherlands. And, well, as to be expected from the Netherlands, it's mostly flat. It actually lies below sea level. And this region is especially used for tourism, but also for agriculture. And tourism especially is also based on kind of boating, taking your boat on a weekend and drive along the channels, which is of course a water resource and that plays an important role here. And what we also kind of, well, also kind of part of the stakeholder group here, also kind of agriculture and tree nursery. And to see kind of the challenges, this works this way, yeah. So due to climate change, there's increasing competition between the different water sectors. Well, obviously, especially during droughts, because then some measures are taking place that kind of might stop the possibility for boating people, for instance, to go along the channels. So what happens if there's kind of a low run of water and from the Rhine entering the Rhineland area, then some channels might have to be closed down to maintain the channels at the kind of coastline to make sure that there's enough hydrochloric pressure to kind of prevent the salt water from intruding the Netherlands and having kind of salty soils in the end. So that's kind of very high level the issue. So what the Rhineland area is, it's vulnerable to both flooding and droughts. And as said, kind of if there's a drought, there's a risk that salt water might intrude the country and that you might have saline groundwater and that might kind of ruin the soils for agriculture in the end. And the projection here is that the climate change might kind of intensify this issue on both sides. There might be more extreme wet events, but also more extreme dry events here. And the sea level might even rise. So putting further stress on this region. To discuss those different issues on the stakeholder board, there have been the recreational tourist groups for tourism boating, the regional water board, but also agriculture and forestry representatives that we kind of brought on one table to discuss what are your needs, what are your requirements, how can we kind of make a tool that is accessible to all of you and provides information that you haven't had before, and it kind of is easily accessible. So to start with, it's kind of a simple application that also runs on your mobile phone, this website, and then you can choose from which part of the stakeholder groups you belong, and then kind of get a different selection of different climate information services, which is up to those 4 possible selections. And the first is kind of the drought monitor that gives you a kind of calendar week summary of what the drought situation might be. And if you kind of open up this monitor, you get very simplified, kind of color-coded first impression, but then you can also kind of open up those tools and you get a more detailed explanation of what's happening here and what is the reason for this indicator, why it's still red in this case. And here it says kind of there's enough water in the Rhine, so that's good, that's green in this case, but there's still a precipitation deficit. So that's the 2 indicators they wanted to use here because they have implications for their own management procedures. So it's always the precipitation deficit that might be an issue, or the runoff at the Rhine. So there's enough water coming down the Rhine this week, and also the overall situation seems to improve over the coming weeks, as we know kind of there's a bit of rain forecasting for the next period. So that's what we see here in this kind of simple overview. And then you can directly go to more detailed information if you like, or if you say that's enough for me to know, I can take my measures. That's also fine. For the recreational tourists, you might get a warning here. So if there's an issue with the water supply, that some channels might be closed and that you might have to reroute the route that you have planned to go from A to B here. What you can then get also is a more detailed impression of the runoff at Lobit. That's kind of a measurement station close to the border where the Rhine enters the Netherlands, and gets on one very left side, you see kind of the observed runoff, and then you get the modeled runoff based on different weather ensembles, and that's calculated by SMHI, our Swedish partner here, the E-height model, and then kind of calculated based on the weather predictions. They calculate the runoff, and that's the projection you see here, which fits quite well, given that it's just kind of an indirect measure here. And you also see some baselines which kind of ask the water authority to take some measures here if we cross this red line for the future. But you can also move to the precipitation deficit map that is calculated based on data from Copernicus. And you also get, if you click on a point, the kind of the time series of this point, so you can see based on observed data what the precipitation deficit has been here in the past, and then also get the forecast for the coming weeks to kind of see what's going to happen and how this might evolve. And this kind of fits the overall view that we have seen, that it's kind of going to be kind of the stress going to be lower because there's going to be rain to come and the precipitation deficit is going to be accumulated. So it's always starting kind of with the season in April. But you can also move in time for the map, so you can see how this kind of changes spatially over time and see kind of what the different values mean. And well, it's the same color coding here for both the figures and also the maps to make that comparable as easy as possible. And the kind of overview uses kind of the maximum value for the entire Rhineland region. That's kind of this black contour line here. And so that we could have this kind of simplified calendar view that's mostly addressing and mostly used for the general public to use that. And that was kind of the idea behind the stakeholder requirements. That brings us to a completely different location, Andalusia in Spain. So kind of a more hilly region. We have a lot of kind of agriculture here going on, and in the Mediterranean climate with different olive tree plants, for instance, but also forestry. And here the Living Lab decided to kind of analyze climatic variables so that we can support the different agriculture features and farmers and cooperatives here working on kind of livestock farming, but also olive oil production. to kind of take better informed decisions how to operate and what to expect in the future in terms of turnout of their production. The challenge here also is on the climate change that we kind of expect higher temperatures. There's already a shift in the seasonal timing, and also observable in the data as far as we have seen during the I-CISK project, also a shift in precipitation patterns. And of course, this kind of changed the constraints as I mentioned in the beginning, and that kind of changes how you could do your agriculture activities here. Stakeholders, it's a pretty large group of stakeholders, so I didn't name them all, just take a look at the logos here on the right-hand side. But to summarize, it's a group of local and regional organizations, authorities, farmers and their cooperatives, and also local and regional data providers for weather data, but also for water table measurements, for instance. Here we developed in the end 7 different climate services. Most of the analytics has been done by Gräler from Barcelona, and then we kind of developed the visualization tools around it and made the kind of data available and brought this together. So this is kind of their own landing page, and then you can click on one of those climate services and you get some more detailed information. This is, for instance, the forecast of the next coming 6 months here for temperature values. So either you have kind of a map here showing this is now the prediction for December, but you also get the time series plot here to see for this location, and the kind of different lines are different quantiles to look at how the temperature forecasts looks like for the next half a year here. On a monthly basis, every month there's a new forecast for the next 6 months to look at, which helps farmers to kind of decide what kind of measures need to be taken, also in terms of precipitation and irrigation measures, for instance. But what we also kind of learned from them, that it's not only important to have this kind of forecast for the next half year, for instance, but also to be able to look back in time. So they have kind of interpolated and aggregated all the data from all the measurement stations for the last 30 years and provided then interpolated maps so that you can start to really assess kind of how is it changing. And here's the difference between the year 2000 and 2024 for May. And then you have kind of a slider here of the map, and you can slide from left to right to see kind of what is the difference between those different data sources. So you can walk back in time and see how different has it really been. You can look at temperature, precipitation, and also drought indices of different kind. And also here we have the functionality. If you click on a point, you can switch to a time series plot so that you see kind of how this location has been evolved over time, and can look for trends and patterns that might help you to better understand it. And looking back into the past is so important because then people can put the predictions into context. There's some kind of common knowledge about very extreme events, very bad years, and if they can compare kind of the forecast to some of those experiences they've made themselves, those forecasts become much more valuable and reasonable and acceptable to them. And so that's kind of one reason why we have those kind of look into the future, but also to look into the past to understand where we're coming from and what does it mean. You have this kind of time series plots, but there are also different possibilities to compare years, for instance. So here we selected, as on the slide before, 2000 and 2024, and then you can see kind of the different amounts of precipitation, how it's distributed over the year, and also the temperature over the year, how that was different between those 2 years. And that extends also, as briefly mentioned, to drought indices, where we here, for instance, compare the drought indice for 3 months, the standard days precipitation evaporation index for 3 months and for 24 months on this scale. It also works on a station level, so that we can not only compare the entire interpolated map, but also the original data. And also here there are many different possibilities to compare different climatic data over different time periods, over different months, comparing 2 stations, comparing 2 years. And it's just an example where we can see how those kind of month of May, what we're looking at here, developed over the time. So how different is the May over all this kind of time period that we have in the database, and compare that here for temperatures. and for precipitation. And you see 3 temperature lines because that's also kind of the minimum, mean, and maximum daily temperatures, which is very important for agricultural processes to have those temperatures available. So you might have to speed up a bit here. We go forward to another kind of climatic forecast. So it's not only the next 6 months, but we also go up here to the year 2040, for instance. And we also see, for instance, the same indicators, precipitation and temperature, which are important for agriculture, and that we see here as an example. Also for agriculture, for instance, important these so-called summer days, which are here kind of on a 10-day basis. And if we also here back in May 2040, we see that there are already up to 9 or 10 summer days, which means kind of temperatures above 30 degrees in this kind of southwestern part of Andalusia, of Spain. So also here you can see how this kind of pattern of colors changes over the time periods. And also briefly said that we're going to have water table management, water table measurements. So there are also hydroclimatic indicators and different selections here. So just a simple view of the water network and also the different points where measurements have been taken. And final slide here from Andalusia. Gräler had put a lot of work into the prediction of the olive oil model here, and based on the modeled components, and this is kind of the prediction, which looks pretty bad for 2040 in terms of the produced olive oil amounts. If you kind of go back in time and look at years close by, this is mostly green. So this is kind of a huge change here to be expected due to different climatic conditions in the future. There was a lot about climate change adaptation, but we also have some tools more towards disaster risk management, and that's happening in the Directed project, where we have 4 real-world labs. So one is the Rhine-Erft region here in Germany, then there's Emilia-Romagna in Italy, the entire Danube catchment, but focusing on Vienna and Zala. Zala is a region in Hungary, and the capital region of Denmark, which I will use as an example here to illustrate the tool from Directed. The capital region of Denmark, we focus on the Varebro River and the Roskilde Fjord, which both have kind of suffered from extreme events recently. And there's also huge interest of the population to better understand what can be done better, and also kind of how to better interoperate between different authorities and organizations so that we can address upcoming disasters better prepared. And there's especially a challenge to kind of improve the cooperation across administrative boundaries for coastal and also fluvial floodings here. So the tool has a slightly different outline, but it's also developed in the Open Pioneer Targets framework, as mentioned. So just a different design option that we choose here based on the recommendations and requirements of the stakeholders that we work with. And here in this slide, you see, for instance, real-time data integration from the Danish Meteorological Institute. And this is kind of the forecast of the sea level deviation compared to the mean value for tomorrow, or kind of for tonight. And it's kind of most likely also based on, or kind of due to the amount of rain that is coming that we see here, so that there's going to be a race, and also based on wind, of course. So those fjords are going to fill up with water, and that kind of stresses the kind of flooding risk. If you then have at the same time, for instance, also heavy rainfall inland, and kind of the rivers can't empty their water to the sea, that's kind of an additional risk here of flooding, and that's what they wanted to understand. So they have different tools here. They can do simulations, they can do modeling, they can integrate this real-time data, but they can also look into observed data from the past, and also look into the different flooding extents from the past to better understand what's happening here, what's going to happen in the future. And for instance, comparing here for a climate projection in the future, which is kind of a moderate emission scenario that we selected here for 2 different return periods. for 20 years and 100 years. And then there's also this layer swipe functionality to kind of see how different it is. So on the left-hand side of this layer swipe, you see the 20-year return period. On the right-hand side, you see the 100-year return period, and can assess the different impacts that you might see. And also what's always debated for the disaster risk management and adaptation tools here, kind of which option is the best option to choose. And the partners from ETH, they developed the Climada tool, which is a multi-criteria decision-making support system. And we developed the front end for it, integrated into the sort of data fabric, how we call it, directed the web platform. And here in this web platform, you can then kind of tune the different parameters. You see the different importance, you give different aspects, and then you get a rating in the end, which option might be the best option for you to go forward with. In this example, it was building a barrier, kind of changing building codes so that different protection measures have to be taken in different areas and change those kind of to higher values, or even relocate people or infrastructure that should not or cannot be flooded. And kind of among those three measures, there needs to be a decision taken in this setup. And that's what this MCDM tool helps you to take those decisions to have better disaster risk management opportunities. That's for examples. Time is running. Let's come to some concluding remarks and a brief summary here. So what we have produced as outcome from those two research projects, so the living labs we work with, they have received and validated information tool that's really tailored to their needs and to the kind of daily questions they might have, and that they actually currently already use to kind of support their decision taking across different living labs, and I really kind of see it as a helpful tool that has lowered the barriers and kind of closed some gaps for accessing the data. So they always knew that there's some data out there, but how can we access it and how can we make it meaningful to them? And that's what kind of the outcome of the research project provides, that this is easily accessible and usable. There's open source code, of course, developed, and that's available on GitHub, different for both projects. They both have a GitHub organization where you can find all the repositories with the different source code of the prototypes that we have developed. So what we take as a conclusion here is that you really have to unite the different stakeholders that use here the same resource or resources, so that in the first place you have to foster understanding and then appreciation of each other's perspectives. So that's kind of very crucial from our learning, to bring together those people that most often talk very little to each other, even though they use the same resources here. And that was always the first step, to bring them together, to kind of understand each other's perspectives, and then start to learn together what are our options, what can we do, how should a tool look like that helps us to kind of better plan ahead for the future changes to come. Co-design is pretty time-consuming, but also very valuable and also educative for everybody involved, even approach, and that's in the end very rewarding when we can go here kind of and develop a tool that's really appreciated and used from the beginning and really well understood from our users. And also there's plenty of data and information already available, but it's kind of fit in different silos at different organizations, under different APIs, on different level of granularity, different labels, and so forth. So we have to use this data, but we must bring it to use by the people. And that's kind of a huge challenge here, to make that into meaningful information products and help people to use it. So kind of our statement, impact statement here would be that the kind of co-developed and use case specific open source climate information services, that they have improved the data accessibility and also the data literacy of our users and stakeholders we work with, and also are made in a way that they can be educative and that you get additional explanations to different variables and tools to see, and that contributes to smart adaptation and to also fostering informed decision taking, so that we can reach, hopefully, a more climate resilient and sustainable future in the end. So that's what we take from the two research projects. That's not the end. We'll continuously evaluate the different solutions. There are discussions ongoing to deploy the solutions at members of the Living Labs, for instance. So they really would like to take it up. The prototypes will kind of go into further development and also serve for the tailored information products. So they know we have a basis, they are easier to expand. And their idea is to integrate augmented reality, virtual reality approaches, integrating more towards the large language model integration, to kind of make that more user accessible, but also helping it to explain what you see on a map. That are further ideas to work on. We're going to work on the integration with the urban digital twins here, so that we can support urban planning and urban development scenarios. Great. So I hope we could caught your interest. Then be kind of get involved. You can access the project prototypes, where I showed just screenshots on under these two links and addresses, so you can get the slides afterwards, of course. You can read about the project results on the websites. There are also policy briefs that have been developed in I-CISK. There's a MOOC already available from I-CISK on the co-creation of human-centered climate services. And if you're interested in uptake, customization, developing your own open source solution, reach out to us, to me, or to our kind of general company address. So don't stop here, please go on. And then, as initially mentioned, I have to acknowledge, like to acknowledge all our partners from I-CISK, especially Ecosistema, who's kind of a company in Italy with whom we co-developed the climate services that you will see online, and also the partners of the Directed project. Also here, Ecosistema was one partner where we kind of closely collaborated with, and of course the European funding. So both projects have received funds from the European Union, one on the Horizon 2020 and the other on Horizon Europe project. So thank you for your attention. That's it from my side for now, for a bit, and then I will look into the questions you might have. And yeah, thank you for your attention.
Can you hear me?
Yeah, Bruce, I hear you.
Great. Thanks, Ben. I think it was a very clear, logical kind of a presentation of these projects. I'm fully aware that when you have big, complicated projects, getting it across in a very straightforward, clear, understandable kind of way is not a minor challenge. But I think you rose to the challenge very well. So thank you very much, Ben. When I looked at the Q&A, there were no Q&As. So let me just check that it's still the case. Yeah. So just a few points from my side. Ben, when you're involved in projects with data from all over the place and different languages and so on, how do you deal with the semantic issues?
Well, ideally, they're kind of very well documented data sets that we use, but that turns out to be hardly ever the case. So in the end, we really needed kind of the expertise and the explanations from the real-world lab stakeholders and hosts in the end to kind of translate, to help to understand, to explain the differences between those different semantic aspects. And in the Directed project, there's kind of also the connectivity hub from SEA developed. There you can find, or there's an integration to the data fabric where in different terms you can kind of click and you end up in this connectivity hub, and you can look up the different semantic meanings that you have there. That's currently available also only in English, but that's kind of translated in parts so that you can really matchmake those different meanings from semantics. So in Directed, there's really kind of this built-in system to deal with the semantics. In I-CISK, we build it really on the interactions with the real-world lab stakeholders.
Okay, thanks very much. The next point I would really like to make is I see you included Lesotho into it, which is obviously not part of Europe. I spent a lot of time there in 2019 doing work for the Lesotho government, so I have some understanding. Now, did you find things were very different between Lesotho and the rest of the European data providers and people you worked with?
Well, we worked in Lesotho through the Red Cross from the Netherlands. So they're kind of the real-world host at that specific location. And we were in the lucky situation that they had kind of a lot of data and data access that they could get and could directly use. So that was kind of an easy task for us. But of course, you see there are very different approaches, how things are organized, how data set and resources are managed, how discussions work in those real-world labs. So that has a very specific and very different location compared to the other locations we've been working with. But kind of due to our partner, the 510 from Red Cross, that was kind of data-wise pretty easy to access and to use.
Okay, okay. And did you take cyber issues into account, you know, like cyber threats, hackers and that kind of thing into account in the products that you were developing, are developing?
Well, they are developed at the state of the art, let's say, but there's also a particular deliverable also on ethics and security, where we kind of discuss also the impact. So also the unintended or even unintended misuse of those tools and applications. So if you would like to kind of take decisions in a certain direction, you could tune the input data sets, you could tune the models so that you get the result that you would like to see. And there are kind of mechanisms built. So we can't prevent people from doing it, obviously, but we give recommendations at least to warn people or make them aware so that it doesn't happen unintendedly. And then, of course, the data fabric has an interchangeable interface. So you could use different models to ask the same questions, and then you could compare the answers and see if one of those models might have a bias. So there are some concepts and ideas integrated to kind of avoid this kind of fraud of the infrastructure.
Okay, yeah, thanks very much. I see we've got what, 2-3 minutes left of our time. Is there any comments, questions anybody would like to raise? If you could maybe just put up your hand, digital hand, as you could see at the top of your screen there. Is there any questions or comments from anybody in the audience? Anybody? No. Okay. Ben, can I just say thank you very much once again for a very clear, logical, nicely presented exposition of the work that you guys have been doing, and keep going. I think it looks great. And we will provide the recording of this particular webinar presentation. We will be providing it on our access on our website and through, I think, Ada, is it LinkedIn that we will provide a link?
Correct. Yes.
Yeah. So if you kind of track EUROGI through our website or our LinkedIn facility, then you will see access to this recording. So thank you very much. And before I just close it all down, Ada, I'd like to thank you for doing all the background work to make this flow succinctly, smoothly, and very well. So thanks for your contribution as well. Okay. All right.
Thank you.
Thanks, everyone.
Bye.
Thank you.
Bye.
Thanks for listening. Bye-bye.